So these changes cause different impacts on the virus. So depending on the environment that they are in, they are able to survive or actually are a dead end. The majority of these changes are actually a dead end, but some cause a benefit to the virus. So the process of changing and selection and so on, we call that viral evolution.
You say a dead end or beneficial. What are those two outcomes for a virus? What does that mean?
COVID-19 virus بيتغير باستمرار والأعراض بتتغير. If you think of it, the virus is really trying to find a balance. Because if it makes too many changes, then it's unable to reproduce itself. It doesn't work anymore, so to say. But if it just makes enough changes, then it can adapt to its environment. So it's really finding that right balance for the virus.
There's no brain in the virus. The virus isn't thinking itself through, right. So it's just a process where it replicates, and then it's shifting as it replicates.
Yeah, that's right. No, the virus doesn't have a brain or eyes or ears, but still, it reproduces a lot of itself, and by doing that, it makes a lot of errors. Having said so, there's also a mechanism that this virus has. It's called proofreading mechanism. So every time it makes a copy of itself and it makes an error, or you can think of a typo in a sentence or in a word, this error is then corrected and replaced with the correct letter. So this is a mechanism that the virus has to make sure it doesn't change too much, but it does make a few changes, and we're closely monitoring those changes to see what
So you're speaking about, now are you speaking about the virus that causes COVID-19, the disease? You're saying that one has this kind of proofreading mechanism, or do all viruses have this proofreading mechanism as well?
Well, in the group of viruses that COVID-19 is part of, it's only the ones that are quite large in terms of their genome. So this is a bit technical, but the virus is 30,000 letters long. Because it's so long, the virus really needs some help to making sure that whenever it copies itself, that it does that correctly. But as I said, it still makes some errors, and those errors may have an impact on viral countermeasures or how the virus behaves or what the virus will look like.
So we'll keep talking about that, and please ask your questions for our expert here. Anything you want to know about how viruses change. Peter, I want to bring you in now as well. So we talked about the virus changing itself. Recently, people spend a lot of energy and attention watching mink and human interactions in Denmark because of some changes happening there. Can you give us the background story a little bit and why everyone, including WHO, was so concerned about that?
What happened is that the virus jumped from humans to mink and started to infect mink in different
يوصل للمينك ده حيوان مش موجود عندنا في مصر ولكن في بلاد تانية ومن المينك بيوصل للبني آدم غير بقى بقية الحيوانات التانية اللي ما بيوصلش منها للبني آدم.
Some of these changes, some of these new variants of the virus jumping back to humans. And that was the big worry for us because when we see that, we are of course afraid that one of these variants, one of these changes, one day would be a nasty one for us and would start another series of problems with the new variant.
فده حاجة خطيرة إنه يتنقل من المينك للبني آدم.
As I said on meetings with you when you were explaining this, is that when the virus is in humans, we're all kind of similar in some ways, and the virus changes a certain amount when it's in humans. When it's gone into mink, and mink being so different from humans, there's sort of pressure on the virus that it needs to change more, and therefore when it comes back into humans, we might be looking at a much more different virus. Is that, have I captured that?
Correct. Remember that the COVID-19 virus that we know very well by now is a fully human-adapted virus. It doesn't need to adapt further. It doesn't need to change when it circulates in the human population. It has a perfect environment there. But when you put it in the mink population, as you said, it's a new environment, and it tries automatically, as Frank was explaining, to adapt to these new environments by making a few changes. Of course, it's not an active process, but it's just a viral biological process that happens naturally.
عشان يتأقلم مع المينك بيغير نفسه بطريقة بالبيئة الموجودة في المينك ده.
You will have all these random mutations and changes, and nature will select the ones that are most appropriate, most beneficial for the virus in this new environment.
This is a question for you, Frank. Do symptoms necessarily change when the virus changes? It's a question from Facebook. The way our friend put it is, do symptoms change when the virus mutates?
Yeah, so we've been actually following this quite closely to determine if different kind of mutations have an impact on disease progressions or symptoms. And actually, so far, what we have seen, it doesn't seem to cause any differences in symptoms. So it's just the same clinical presentation of symptoms as you would see with your quote-unquote normal SARS-CoV-2 or COVID virus.
So there's a few other similar questions. You're talking about symptoms, but people also want to know, there's a question on LinkedIn, for example, what are the risks that as it changes over time, as it passes around even amongst humans, that there'll be an effect on the vaccines, the potential vaccines that are still in development, and how effective the vaccines can be?
Right. Well, remember what I just mentioned. The virus is relatively stable, and on top of that, it also has what we call this proofreading mechanism. Nevertheless, the virus does change, and depending on where in that genetic material or in the recipe of the virus that change takes place, it may have an impact on what the virus looks like, the shape of the virus. Because remember, we're talking about this coronavirus, which is sort of like a ball with protruding pins coming out of it. And these pins, if the changes happen in that pin, it may look a little bit different. So the possibility exists that it may impact the virus, may impact the vaccine. But so far what we have seen, the virus is relatively stable. The vaccine is also developed using the existing virus. So we haven't seen any red flags just yet. But as I mentioned, we're closely monitoring this.
لما بيتغير شكله وشكله احنا عارفينه ان هو عبارة عن دورية وفيها شوك. الشوك ده بيتغير.
The beginning of the outbreak.
لكنه ثابت حاليا وهي بتسأله عن اللقاح، فهو بيقول لها حسب تغيير الفيروس ده، ولكن هو ثابت الفترة دي.
What do these changes really mean? And just recently, after we've always been looking at it, we've also started to have a bit more structured working group approach to these changes in the virus. And this is a more dedicated working group that we have established, and that is what we call the SARS-CoV-2 Virus Evolution Working Group. And with this, we can take a more systematic approach at looking what these changes mean and how we're going to tackle them and better understand them.
I think what you explained off the top as well is that the tests to detect
are with Lego blocks or something like that. And if it was built with known blocks, for example, with all red or blue blocks, when you look at the final product, you will recognize that it's made by these blocks. But here we have not that picture. We cannot recognize elements that would have been used to construct such a virus. So it's, everything indicates that it's a natural virus.
That having been said, we are still trying to understand how this virus came from the animal world, which is where a natural origin would be, into the human world. And Peter, you're working very closely with the international group of experts that WHO has convened to do this virus origin studies. Can you tell us a little bit more about what that process will be, how we go about trying to understand that recent history of the virus and how all this began in the first place?
What we try to do is to figure out what happened last year before the first case was detected in December 19. Remember, the first case was detected in Wuhan, in central China, and after that, we all know the history and the course of the pandemic. But before December 19, we don't really know what happened. We don't know how the virus jumped from its most probable natural environment in bat population over to humans. And it's that bit of the history that we need to reconstruct and understand and try to define. And the process to go about that is to what we would like to do with the international team and counterparts in China is to go back in the Wuhan environment, re-interview in depth the initial cases, try to find other cases that were not detected at that time, and try to see if we can push back the history of the first cases, if we can find all the cases that could have important information to tell us about where they may have picked up this virus. We should also look again at the famous wholesale markets where the first cases were detected. Look at everything that went in and out of that market at that time, and try to find out where these products and animals and food products came from, where the workers working in this market who got infected severely in December, where did they came from? Did they all have some commonalities somewhere outside Wuhan in some of the countryside or provinces or farming environments or hunting environments in southern China, or perhaps even outside China, and then concentrate in these locations, concentrate in these environments, and try to then there conduct more in-depth studies, survey number of animals, number of humans in that area, and try to see if we can find some clues that would tell us the early history of this
epidemiological work, and very human as well. You talked a lot about needing to talk to people and understanding kind of the background of their work and their life, their exposures, and so on.
Yes, and it can be both time-consuming and quite complicated, because it's about trying to recall the memory of people in that period, and it takes time, it takes special techniques to get that kind of information out of people, and then connect the dots. You might get bits and pieces of information here and there that in isolation do not mean much, but when you put everything together, you start to see a picture.
A very good clarifying question asked by Teresa Stemeye, who says, SARS-CoV-2, is this something different from COVID-19, or is it the same thing? I think this one's free.
في واحدة أخت بتسأل هل في فرق بين SARS وكوفيد? It's actually called SARS-CoV-2. 2 because we had a SARS-CoV-1 as well. But now this particular virus is the SARS-CoV-2. And it causes the disease COVID-19. So sometimes people change these up, but strictly speaking, the virus is SARS-CoV-2, the disease is COVID-19. But, you know, in these kind of discussions, if you say COVID-19 virus, it's fine. Yeah.
We won't dock people points for that.
Exactly.
And it's called SARS-CoV-2 because it's actually close to SARS-CoV-1, right? And it's not the same virus, but it's close enough that people who name viruses suggested that should be the name of the virus.
Yeah. So viruses have families, and this particular SARS-CoV-2 also fits in the family of coronaviruses. And perhaps I'll use this opportunity also to say a little bit about technique in the laboratory that's also relevant to the origins discussion as well. That's a technique that we call sequencing. So sequencing is actually looking at the genetic material of the virus, so the whole recipe. And then you get, so this particular virus has 30,000 letters. So with sequencing, you read all these letters one by one by one by one by one, and you have, till you have all 30,000 of them, so you know what the composition of the virus looks like. Then you can use these different, what we call sequences, in the laboratory to relate different viruses to each other. So when you do that, you can see the different coronaviruses grouping together. You can see other viruses not grouping with them. So this gives you an indication of where this virus belongs. The sequencing is also important if you want to know about these changes, because how do you actually find these changes? You actually need to know what the virus looks like at the molecular level, or with all these letters, to see if it has changed from before. And then you know that this virus has changed or has had what we call a mutation. So it's a really important technique, and we have around like 200,000 sequences submitted already from all over the world, and it has been a really global effort and collaborative undertaking to get this all done, and it's really very impressive.
This is a follow-up question. It comes from LinkedIn. There's been a couple of other similar ones. How many variants or subtypes of SARS-CoV-2 have been identified until now?
Yeah, it's all these variants. I mean, if you really think of it, there are many variants because the virus changes. Some of them survive, others don't. But we have seen that when you do this type of grouping of the virus, even within SARS-CoV-2, there you can see like several different clusters or clades appearing. They're not very different from each other, but you can still distinguish the different groups. We're still discussing how best to delineate these groups because different technical groups use different terms for that. But generally speaking, we do see what we call the clades appearing.
And there have been sort of, I hate to use the word trends, but there is a sort of a certain variation of COVID that came along earlier and became over the past many months more the dominant one that we see around. Yeah.
So this one actually, people who are actually watching us online may actually have heard about this particular change. It's called the D614G. So what it means is the D has been focusing on this particular virus. So early on we looked at, for example, what I just said, these sequences, and we can slowly see this particular virus becoming more dominant. So then the research goes to the next step. So in the lab we look at what does this change mean in the lab? Like, how does it make more copies of itself? How easy is it to get into the cells and those kind of things? And as we progress, we can also see studies in animals, for example, going from one ferret with that virus to another. So we can see that the virus seems to replicate faster in the laboratory, also transmit between we haven't seen any differences in clinical presentation of this virus in the humans, or it also seems to not affect vaccine efficacy as well. So
clinical presentation, how sick it
yeah, exactly. Exactly. Yeah, that's right.
It's a virus that makes some people very sick, but it hasn't seemed to affect a different part of the population or be even worse than it already is in a way. Is that what you're saying?
That's right.
Yeah. Peter, some questions on the animal side again. So Maud Mohidin is asking, is there any case of an animal dying from COVID-19?
Yes, for example, the mink are dying, getting sick and dying from the disease in a very similar way the humans are doing. Otherwise, very few animals have been shown to be susceptible to the virus or be able to be infected, but we only have a few examples of cats and dogs and a couple of lions and tigers in the zoo.
العدوى دي زي الكلب والقطة بس ما بتنقلش للبني آدم.
And in the mink population, as I said, we see animal dying.
But we're looking, right? It's not that a few scientists have looked at tigers and lions and a few have looked at mink and therefore we know about how it affects those animals. My understanding is that scientists around the world are looking at various animal populations. Can you tell me a bit more about that?
Yes, of course, we are in the search for the animal origin of this virus. We are also looking at different animal species to see if they are susceptible to the virus in the same way we are. So there are studies being conducted on all kinds of animals, and in addition, and of course, focusing on the animals with whom we are more in contact with on a regular basis, and that would be all the farm animals, pigs, cattle, sheep, etc. but also the animals being raised for commercial purposes, such as the mink and the ferrets and foxes and so on. And of course also the other animals we're in contact with as companion animals, our pets. A lot of our pet species are also being studied. So all these animals with whom we are in regular contact are of interest to us because we want to protect them from being infected by the humans, and we also want to make sure that we don't create a risk for us again by creating a new reservoir for the virus in a new animal species.
This is a slightly different question, and it's a bit more of a big picture, but I think it's for you, Frank. This is a question that came a little while back on LinkedIn. If I understand correctly, the 1918-1919 influenza virus, the one that caused that giant pandemic back then, changed to be more dangerous in the second wave. What was the nature of that mutation, if we know? I don't think we're going to be able to revisit that history, but we'll take the second part of the question. What's the likelihood that there would be a similar change in another wave of COVID-19? Do we have a way of estimating percentage chances of change?
The question is an interesting one, and it's important to also compare actually the 1918 virus, which is an influenza virus, to the SARS-CoV-2 virus. Influenza actually behaves slightly differently than COVID-19. Influenza can change in big chunks, so to say. It can change the way it looks drastically. So then when it changes that much and it goes into the human population, most of our immune systems or our bodies are unable to recognize it, and we're still susceptible. So that can cause a huge wave of new disease. As I just explained, the virus that causes COVID-19, SARS-CoV-2, changes much more gradually. And we as scientists call that drift. So the virus slowly drifts away into other different changes. So the chances that SARS-CoV-2 makes a dramatic shift, like we had seen in the 1918 virus, are unlikely.
Unlikely given current circumstances,
yes.
Unlikely if it's mostly within the human population,
exactly.
All those other provisos as well.
And also the nature of the virus itself.
Because it's a coronavirus, or because of this particular virus?
It behaves differently than an influenza virus.
Yeah. I just wanted to make a point of clarification as well. Something we hear Dr. Mike Ryan say often in press conferences is because people do ask, has the virus changed? Is that why there's been a second wave? Is that why some countries are seeing a third wave? Is it because changes in the virus? And our best analysis is that no, it's more about human behavior, what we're able to implement, the kind of measures that countries and communities are able to implement, because some countries have been able to bring it under control and it's been much tougher in others. So Dr. Mike Ryan will always say it's about what we're doing. It's not so much about the virus itself. We have a kind of a good sense of what...
Well, the logistics available in the city was geared towards combating the outbreak there, so there was no opportunity, no resources to do these more long-term studies into the source of the... So we had to wait until the situation was more calm and in a way in Wuhan. With regards to other similar events, yes, it's a long time since this started. Ideally, we should have done many of these studies immediately when the event started in December, January last year. But with SARS-1 back in 2003, it took months and it took more than a few years before we had a good understanding of the intermediate animal host that was the source of SARS and of the link to the original source in bat population. That took many years before these links were made, and we never found the virus in any of these animal species. It was just a strong suspicion that we could reach. With MERS that started in 2012 in the Middle East, it took more than a year before we made the link with the exposure to camels, and camels being the source of this virus. And that was a little bit by chance. I remember we were called by colleagues in Qatar who told us, look, we have this farm where we have 2 cases that are sick with MERS. We think that the source might be on that farm. Can you come and work with us on that? So we were immediately on the ground, and by sampling and searching that farms and all the animals on that farms, we managed to make the first link to camels and got that confirmed later on. So it took about a year to get that first indication. So this time we're not even a year through this massive pandemic. So it's late, but it's not too late. I'm confident that we still have very good opportunities to learn much more on the origin of the virus.
Just 2 quick questions for you, for your area of expertise. Nick Aina Nadhira is asking, is there a possibility that livestock or pets might actually need to be vaccinated sometime in the future?
That's a good question, and probably short answer would be yes, because we know that cats and to some extent dogs are susceptible to the virus. So if the virus is still circulating in the future around us, it would be a good idea to also be able to protect them in the same way we're trying to protect humans by developing vaccine for humans. And for farmed animals, for domestic animals, the same. We know that some species may be slightly susceptible. They're not as susceptible as what we see in the mink, so it's totally different scenario, but they could become more susceptible again if the virus changes, so it might be also a good idea to be able to vaccinate pigs and other animals in the future. They do not get sick, they do not transmit the disease easily, but in some cases they may be able to get infected by the virus, and again we don't want that to happen too often with the animals we're in contact with.
So while all these experts are working away on developing a human vaccine, would you estimate that in parallel there are animal health specialists who would already be working on a vaccine for animals, or would they have to wait for a human vaccine to be ready and would somehow work around that one to make it animal one?
The 2 efforts could run in parallel, but once we will have a vaccine for humans, it would be much easier to adapt to even use the same vaccine for animals. So there is no reason to duplicate efforts, in particular in the first phase of the development of a vaccine.
And another question for you, this is from Periscope, from Jane Gabbard, who wants to know, would stopping human encroachment on wildlife environments help prevent this kind of outbreak? So it's really a looking towards the future kind of question.
It's true that many of these new emerging diseases that we get from contact with animals, in particular with wild animals, are of concern, and therefore the logical quick fix in a way would be, well, let's stop to get in contact with wild animals. The problem is that thing to achieve. But it's true that the more we move into areas and establish ourselves and establish settlements in wild environments, the more we get in contact with new viruses and bacteria and the like, and therefore we increase the risk of this disease jumping to the human. So managing better our interaction with our environment, in particular with pristine nature areas where we have not previously been actively establishing ourselves, is probably a good idea. Unfortunately, we are growing in number on the planet. We are taking over bigger and bigger parts of the landscape around us, and therefore it will be always a balance between what we should and what we can, and will be also depending on how good we are at managing our environments and our interaction with the environment. It's very complicated topic.
Yeah, it's really about how humans, how we care for this planet in a way. I'm going to wrap up now. Thank you both, Frank Konings and Peter Barak, for being with us today. If you have follow-up questions, you can drop those in the comments too. That helps us guide what kind of products we need to develop for you. And now I'm going to round up the names of some